Hi everyone, welcome to the revision video part 1 of coordinate and conic, and we'll be doing at least 4 or 5 videos, revision videos for this topic because it's a lengthy topic and difficult to understand and difficult to visualize. Okay, so that's why we'll be staying in touch till the end with conics and coordinate. Okay, so let's start our first question. So the number of integral values of m for which the x coordinate of the point of intersection of the lines 3x plus 4y equals to 9 and y equals to mx plus 1 is also an integer. Okay, so basically we have to solve these two lines. So we have we have mx minus y plus 1 equals to 0, and the other equation is 3x plus 4y equal minus 9 equals to 0. We have to eliminate y because we are talking about x coordinate, so we have to eliminate y over here. So I'll be multiplying 4 over here. That would give me 4mx minus 4y plus 4 equals to 0. If I add both of them, I'll be getting 4m plus 3 times x equals to, that becomes 5. So x equals to 5 upon 4m plus 3. Now, if I put m equals to 0, I can see that it's going to be 5 by 3 and x is not going to be an integral value. And if I put m equals to 1, it's going to be bigger than 5. So for any value greater than equals to 1, for m, any value greater than equals to m1, it's not going to take any integral value. Now, if I take m equals to minus 1, that would become minus 4 and that would become 3. So that would give us minus 1 in the denominator. So that would make it x equals to minus 5. So m equals to minus 1 is one possible number. And if I take m equals to minus 2, that would make it minus 8 plus 3. So that becomes minus 5 in the denominator. And that again gives us x equals to minus 1. So m equals to, again, minus 2 works. Now if I make m equals to minus 3, that would give me minus 12 plus 3. Again, that becomes bigger than, in terms of magnitude, it becomes bigger than the numerator. So for any integer value of m which is less than or equals to minus 3, it's not going to work. We have got just two values over here. So A is the correct answer. Now let's look at second question. The equation of perpendicular bisectors of sides AB and AC of triangle ABC are this and this. If point A is 1 comma minus 2, then the equation of line BC is okay. I think I have covered this kind of problem in the one of the lectures as well. A, B, C, A coordinates are A comma 1 comma minus 2, and the perpendicular bisectors over here is x minus y plus 5 equals to 0, and this one over here is x plus 2y equals to 0. And there are multiple ways to solve it. The first one is, let's say this one is x1 y1 and this one is x2 y2. So how should we get the idea if we don't know the reflection concept? If we don't want to apply that kind of formula, we can simply do it by the midpoint theorem. So let's say this coordinate is x comma y over here. Okay, we know this coordinate. So x would be basically x plus x actually would be 1 plus x1 by 2. Y would be minus 2 plus y1 by 2. So we have got x and y, and now we can put these values over here as well. So if I put x and y in this coordinate in terms of x and y1, we'll get one equation from here. And also the slope of this line and slope of this line, if you multiply them, that the product should be minus 1. So that is one way where you can find out the values of x1 and y1, because we'll be getting two equations and two variables. We can solve them to find out the value of x1 y1. So that is one way to do it. That is the most simplest way. If you don't know the reflection formula. Now if we know the reflection formula, let's see how to do it. In case of reflection, we know that this is the perpendicular bisector. So basically, we have to find out the image of A with respect to this line. So that would give us B. Similarly, image of A with respect to this line would give us C, because this is the perpendicular bisector. Okay. So for that, let's say we have this coordinate x1, y1. So we'll be getting x1 minus 1 divided by A. A over here is the coefficient of x, that is 1, equals to y1 plus 2 divided by minus 1, the coefficient of y, equals to minus 2 times. We have to put this point in this line. That would be 1 plus 2 plus 5 divided by under root a square plus b square. That would be not under root a square plus b square, just divide by a square plus b square. That would be 1 plus 1. Okay. So we have got this 5 plus 2, 7 and 8 divided by, and this 2 gets cancelled out. So basically we have got minus 8. So with this, we are going to get x minus x1 equals 2 minus 8 plus 1, that is minus 7. And y1 equals to, this minus sign multiplies over here, that becomes 8. So y1 equals to 6. Now we have got minus 7 and 6 over here. Similarly, we can find out x2 and y2 over here. So we can write down the equation x2 minus 1 divided by 1 equals to y2 plus 2, not 1 over here, yeah, 1 over here, and y2 divided by 2, y2 plus 2 divided by 2, because we have b as 2 over here, equals to minus 2 times. Now we'll put this point in this line. That would give me 1 plus 2 times minus 2 divided by 1 plus 4. Okay. So this becomes minus 4 and minus 3, and this becomes 6. It becomes 6 by 5. Okay. So this would give me x2 equals to 1 plus 6 by 5, that is 11 by 5. And y2 equals to 2 multiplies over here, that becomes 12 by 5. And minus 2, that becomes 2 by 5. Now we have got 11 by 5 and 2 by 5. It becomes a little lengthy over here if you're not quickly finding out the coordinates. So now we have to find out the equation of BC. So first of all, we'll be looking at the slope over here. So m would be 6 minus 2 by 5 divided by minus 7 minus 11 by 5. This becomes 30 and minus 2, 28 by 5 divided by, this becomes 35 and minus 46 by 5. So that becomes 14 by 23 with a negative sign. Now, if you look at the options, so there should be just one option. There is just one option, that with the slope minus 14 by 23. So that's the B option. So we find out the slope by minus times coefficient of x divided by coefficient of y. So only in case of D, we are getting this kind of option. In all the other cases, we are not getting this kind of option, right? So even without calculating the actual equation of BC, you can mark the answer. So you have to remember, you have to see these kind of options, tricks in such questions, because this becomes quite a lengthy one. Okay. Now let's talk about question number 3. Let PS be the median of triangle with vertices P, Q, and R, and the equation of line passing through 1, 1 in parallel to PS. That's a fairly simple problem. So we have P, Q, R. I'll just give the idea for this one because it's a fairly simple one. And this is 2, 2 over here. R is 7, 3 over here. And Q is 6, minus 1 over here. And PS be the median. So this is the median. So we can find out these coordinates with the help of midpoint formula. That would be 7 plus 6, 13 by 2. And that would be 3 minus 1. That would be 2 by 2. That is 1. Okay. So we have got the coordinates of S. Now there is one line parallel to this median, and that is passing through 1, minus 1. So you can directly write in 2-point format, because slope we can take from here and we know the point over here. And slope for these two parallel lines would be same. That would be y minus y plus 1, basically. Y plus 1 equals to m times m is m we can take from here. That would be 2 minus 1 divided by 2 minus 13 by 2 times x minus 1. Okay, so this is the equation. Now let's talk about question number 4. The equation of straight line passing through minus a, 0 and making the triangle with axis of area t, right? So I'm assuming that a is a positive number over here. So this is minus a, 0. Okay. Now the interesting thing over here is we kind of assume that it will be making this kind of line, this kind of triangle, but it's fairly possible to make this kind of line as well, right? This kind of triangle, because the area given is t over here. It can be either here or here, and area is always positive. If we talk about area, area is always positive, right? Unless we are talking about the integral area, where we are just talking about the integration and not the area. We are just concerned with the integration. In that case, for calculation part, we take the algebraic area, not the actual area. But in all the other cases, when we talk about area, that means simple modulus. Okay, so that would be t equals to modulus of 1 by 2 into this length is a into height. Height is either this one or this one, right? So we get h equals to 2t by a plus minus. Okay. We have got this coordinate or we have got this coordinate. So if this is the case, we have got 2t by a, sorry, 0 comma 2t by a, and if this is the negative case, we have got 0 comma minus 2t by a. Now you have got the coordinates, you have this coordinate, you have this coordinate, you have this coordinate, you can find out the value of two lines by the interceptor form. Basically, you can find out the equation of two lines with the intercept form. So it's by capital A plus y by b equals to 1. So we have both the intercepts. We have intercept A, we have intercept B, and you can just find out. Now make sure that when you are writing the intercept, you are taking minus A over here. Okay, because we were calculating the area, we just took the length. But when we are calculating the intercept using the intercept form, you have to take the intercept value and not the modulus of that. Okay, so x upon minus a would be there, and plus y upon, in this case, minus 2t by a and 2t by a over here. Okay,